Hi everyone, it's November and it's November 3rd and it's snowing outside, so it's pretty crazy today. We're going to start with limiting reactant. This is something called stoichiometry, where we have a reaction and we try to predict the amount of products that we make. And a really simple way to think about it is in terms of making sandwiches. So let's say that to make one sandwich you need 2 slices of bread, 3 slices of tomatoes, and 1 piece of lettuce, and that's what makes a sandwich. So let's say you have 12 pieces of bread, but you have a lot of tomatoes and lettuce, so that's not going to limit you. But the bread's going to limit you. How many sandwiches can you make? So a really simple way you could do this is you just think about it. You know that you have 12 slices of bread. You need 2 for 1 sandwich, so that's going to be 6 sandwiches. You also think about it as writing it out in terms of dimensional analysis if you want to. So let's say you have 12 slices of bread. That's what you're starting with. And you know for every 2 slices, you make 1 sandwich. Okay, and now this is going to come in handy when you have chemicals here. So you're going to use dimensional analysis for that too. So we've got 6 sandwiches here. So that's how many you can make with what we're starting with. Now, theoretical yield then is what this 6 sandwiches is. Theoretically, if I used all of this to make sandwiches, I could get a minimum or maximum of 6 sandwiches. That's the most I can make. That's what we call our theoretical yield. Theoretically, that's how much I can make. Okay, so theoretically, it's 6 sandwiches. Now, the concept of limiting reactant is like my bread. I had unlimited tomato and lettuce, so that's what I would say are my excess reactants, and sandwiches is based on how much bread I have, only 12 slices. So bread, slices of bread, is my limiting reactant in this case. But that's because they told me that it was. What if they didn't tell me what was limiting? And now I have this problem. I have a certain number of slices of bread, certain number of slices of tomatoes, and lettuce, and I don't know what the limiting reactant is. I don't know which of these is going to limit how much I can make. So what I would have to do is just do the calculation for each of these things. Now above, we already did this calculation. 12 divided by 2 makes 6 sandwiches. So that's how much I could make if I used up all of this. But how much can I make if I use up all of this? So I've got 1, 2, 3, 4, 5, 6, and I need 3 slices to make a sandwich. So I have 6 divided by 3. So, or 6 tomato slices, where 3 tomatoes makes 1 sandwich. So I've got 2 sandwiches I can make out of this. Okay, so I can already see that I'm going to run out of tomatoes before I run out of slices of bread, because I'm limited to only 2 sandwiches that can be made. So it's the tomatoes so far. Now let's see with the lettuce. I need 1 piece of lettuce for each sandwich. So for this, I have 1, 2, 3, 4 pieces of lettuce. I need 1 lettuce to make 1 sandwich. So theoretically, if I used all this lettuce, I could make 4 sandwiches. So far it looks like that's going to be the most number of sandwiches I can make. So that's what we call my theoretical yield. So that's my theoretical yield. So that means I can only make a maximum of 2 sandwiches, assuming neither of them fall on the floor or something terrible happens to them. And then my limiting reactant is which one of these ingredients limited me in terms of making only 2 sandwiches. So that would be the tomato. So my tomato is my limiting reactant. So it's important to know the difference between the terms limiting reactant and theoretical yield. Theoretical yield refers to the amount you can make, the maximum amount you could make, based on the amounts of your starting materials. And limiting reactant is which one of those ingredients or starting materials limits you in your theoretical yield. So that would be the tomato. So let's write that down here. Theoretical yield, in this case, it's 2 sandwiches, and my limiting reactant is the tomato slices. So often you're going to be answering questions about both. What's your yield and what was your limiting reactant? Then finally, there's something called a percent yield. Remember when I said assuming your 2 sandwiches don't fall on the floor? So percent yield is how much you actually get out of it. So let's say that you could make 2 sandwiches, but your cat ate one of them. So your actual yield is going to be how many you actually have at the end. So if your cat ate one, then you only have 1 sandwich left. Theoretically, you should have been able to get 2 though. And then you multiply by 100. So in this case, you're going to have 50% yield. You only made half of what you should have been able to make theoretically. That's what we call the actual yield. So now let's apply this to chemistry. A generic chemical equation, we have 2 moles of A plus 1 mole of B plus 3 moles of C makes D. So let's say possible conversion factors are any relationships in moles between these 4 things. So 2 moles of A to 1 mole of B, that's one example. I could say 2 moles of A to 3 moles of C. I could say 3 moles of C is related, makes 1 mole of D. Any relationship between any 2 of these makes a mole ratio. Let's say you want to make 5.7 moles of D. How many moles of C can you make? So what I'm going to do is, I'm going to make D, how many moles of C do I need? So it's a 3 to 1 ratio of C to D. So I'm starting with D, and I need to use this mole ratio here. 1 mole of D, I need 3 moles of C to make that. So I'm going to put that in here. Moles of D need to go on the bottom, moles of C on the top. It's a 3 to 1 ratio based on the balanced equation. This is what I call my mole ratio. And then I just do the multiplication. Now this is 17.1, but I'm going to round it to 2 sig figs because the 5.7 is only 2 digits. So this is going to be 17 moles of C are required to make 5.7 moles of D. And that should make sense because in moles it's a 3 to 1 ratio. 17 to 5.7 is 3 to 1. Okay, so don't forget, this is called a mole ratio, and that's how we jump around in the equation. Let's say we have 2 moles of A and 4 moles of C. How many moles of D can you make now? So I would set this up as 2 separate problems. First do this and go to moles of D, and then do this and go to moles of D. So for example, 2 moles of A, how many moles of D would we make? So I need to set this up, moles of A to moles of D. The ratio is in the balanced equation, 2 to 1. So 2 moles of A to 1 mole of D. I'm going to get 1 mole of D can be made theoretically from 2 moles of A. Let's do the same now with 4 moles of C. 4 moles of C, so now we have moles of C on the bottom, and we're trying to find moles of D that we can make from that. C to D was the 3 to 1. So let's put 3 moles of C to 1 mole of D. So 4 divided by 3, or 1 1/3 moles of D can be made in that case. Now look at what we're limited by, right? Remember with this, the least number of sandwiches we can make was the theoretical yield. So the least many moles of D right here, that's my theoretical yield. I can only make 1 mole of D. What was the limiting reactant then? It was A. A limited me in how much D I could make. So the limiting reactant is A. So the last thing is, instead of starting with moles, we could always start with grams and then convert it to moles and then do this process and then convert it out of moles into grams. So that will be the focus in our next video.